Apologies for the delay, guys. There were some inordinate issues, unavoidable issues, which had to be taken care of. So, is the audio available? Audio and video, right? Okay, perfect. Can we continue now? Okay, right. So, basically, we were talking about the origin of the continents, the position of the various different continents. Where does the position, or what is the present situation and the positioning of the various different continents which exist? So, we had an entire era of geologists who basically adhered to the fact that the mountain formations, the kind of oceanic formations that we see, because this question has always prevailed in the mindset. I'm sure you would also have the same kind of curiosity. Why is it that certain areas are so very deep? They basically form the deepest of the oceans. Why is it that some areas are so very high? They end up forming the tallest of the mountains. So, you had some of the very weird kind of concepts being provided earlier, where the planet is contracting, etc. In 1900s, that is in 1907, for the first time, you had an American geographer with the name of F.B. Taylor. Now, F.B. Taylor, for the first time, talked about the fact that you know what? The continents that we are standing upon, that is moving. Now, right now, it will be, in a way, unwise for us to judge them on their kind of a judgment, or to have an opinion on that judgment, that why were people so very much against that idea that the continents could move. But think about it. A random individual, you pick it up, random individual around you, who would have from their childhood days observed the tallest of the mountains, and who would have witnessed the ground surface as hard it is, and tell them that the ground underneath them is literally moving. That obviously would not be a very acceptable thought, would it? But then F.B. Taylor, when he provided that idea that the continents can drift, there came another group of geographers who were different from the contractionists, who were known as the drifters. And think about it, drifter basically is not used in a good parlance ever. So they were used, and that term was used as drifters to indicate those kind of people who believed that something could move, the land underneath them could move. But F.B. Taylor did not develop this concept. He simply provided this idea and he vanished into the thin air. Then, by that point of time, during the 1700s, during the 1800s, you had a lot of people who were talking about the fact, who had the records of all the ancient plant and animal remains. By that point of time, enough research had been done into the type of rocks so that we could understand when a particular rock came into existence, what was the origin of various different kinds of rocks, etc. Now, you had a German meteorologist or a climatologist with the name Alfred Wagner. Now, Alfred Wagner, he was a German climatologist. And at this point of time, you also have to be aware about the global geopolitics which played out. Because acceptance and rejection of theories at that point of time always was also dependent upon the global geopolitics. Think about it just as an analogy, I'm providing it to you. For example, in today's world, let's suppose a scientist from Iran, let's suppose a scientist from China, or a scientist from Russia provides a particular theory. There will always be doubts which will be casted upon that individual, that I don't know whether that theory is reliable or not. I don't know whether that person is saying the correct things or not. You will cast doubts and aspersions upon that person. But let's suppose the same thing is talked about by an American scientist or an American physicist. You will have a kind of a trust associated. Alfred Wagner was a German climatologist belonging from Germany, and Germany at that point of time in the early 1900s obviously was one of those which was not taken in a good light by the Western scientific world. So, what was the specialty of Alfred Wagner was basically he specialized in studying how over a period of time the climate across the planet has changed. Alfred Wagner was well known for frequent trips that he would take to Greenland. And in Greenland, what he would do was basically he would dig out the ice samples, and these ice samples would contain the climatic records of the past. And that is how he could formulate that, millions of years ago, the planet across or the planet had experienced this kind of a climate. Presently, the climate is like this. So he studied the change of climate. That was his specialty. He had no specialty or no special idea about the interior of planet Earth, about the functioning of the continents, the movement of the continents, etc. He was not well aware of that. Now, as the story goes, that on the eve of Christmas, one fine day, one of his friends, Alfred Wagner's friends, he gifted Alfred Wagner a detailed world map. Now, it was quite rare in those days. Presently, world map you find at the back of the page also. At the back of the book also you find a world map. But that was not the case at that point of time. A detailed world map was a rarity. So he was gifted a detailed world map. Now, when Wagner took a look at the world map, something struck in his mind. He observed that the shape of the continent here, the shape of the continent here, that appears to be very similar. It cannot be a sheer coincidence. Let's assume it is a coincidence, but the shape of the landmass here and the shape of the landmass here again is very similar. Then the shape of the landmass across the western part of India and the shape of the landmass here and the characteristic features of it, they are similar. So like that, Wagner basically looked at various different data pointers which were available. So after looking at the world map, he was intrigued. And somehow he was convinced that, what? The only reason that different portions have a similar land pattern or a similar shape, the only reason that could have been possible would have been because all the land masses would have been one at a point of time and they had drifted away. That is where continental drift, the term, came into existence. In a way, he was much more radical as compared to F.B. Taylor. F.B. Taylor, the poor chap, had only said that, the land masses could move, that's it. Wagner then started studying the evidences in order to understand that is it possible that the land masses could have drifted away. He looked at the geological records of various different places. He looked at the fossil and the evidence of the ancient plants and the ancient animal remains. And he started looking at that. And basically, he arrived at a certain set of evidences. All the evidences pointed to the same direction. And with the set of those evidences, he postulated what is the continental drift theory. Now, the continental drift theory in itself basically was very simple. It talked about the fact that at one point of time in the history of the planet, around millions of years back, you had a giant supercontinent. That giant supercontinent was Pangaea. These are German names, obviously. And he said that it was surrounded by water from all sides, and that is what he named as Panthalassa. That is the ocean of the world. Now, he said that even the present day Pacific Ocean is nothing but the remnant of this Panthalassa. All the other oceans that you have seen, they have been created in between. So he said that look, this Pangaea actually broke. This Pangaea broke into two parts initially. It broke into two parts. In the north, you had a giant landmass which included the present day continents of North America, Europe, and northern part of Asia. He named this as Angara land or Laurasia. And then this Pangaea had the southern portion of it as well. Basically, that is what he named as Gondwana land. You know, this Gondwana land, the name is derived from the Gondwana region of India. Gondwana region is where you find the Gond tribes in India. Because the rocks, they represented a kind of a similarity of structure. Hence the name Gondwana land became prominent. And that would include the region of South America, Africa, India, even the Arabian Peninsula, Australia, many of these islands, and Antarctica. That would form the Gondwana land. He said that the continents have drifted and formed this. Then after that, it further disintegrated. It further broke down. And as it broke down, it basically had this westward movement where North America and South America, they moved west. They broke and moved to the west. Then the other portions, if all of them were joined together, the portions, they started moving northwards. And that is when India, which was at one point of time joined in the region around Antarctica, it covered that distance and moved to the present place. Africa moved here. South America moved here. Australia moved here. So he said that, look, there are two kinds of movements that the continents are experiencing. The westward drift and the movement away from poles towards equator. These are the two movements that the world is actually witnessing, that the world is presently experiencing. But then, when we talk about specialty in a subject is very important if you have to go into the details of it. Wagner's specialty was to study climate change. He did not have any clue about the interior of the planet. He did not have any clue that if I am saying that the lands are moving to the west, why they are moving. But all the evidences that he had, it pointed to the fact that the land has moved. And we will take a look at the evidences. But when it came the time to support that aspect, provide reason for that aspect, the reasons that he cited were so very inadequate that basically the entire concept of drift was ignored. It was rejected. Wagner, in fact, published his theory in the form of a book, in the form of an essay, what is referred to as it was the book which was basically published in 1912. And that was a book which was published in German. So obviously it was not available to the wide world. It was something which was not available to the wide world around him. The world got the English translation of that in the early 1920s, because the 1910s, that was the era of war. That was the era of First World War, right? So obviously the German translations won't be easily available. Now that is when eventually you had the case where in 1920s the world was made available of the translation. That is when the American geologists, the American scientific community also studied that. And they laughed at Alfred Wagner. That look at the reasons that he has said, reasons for the shift of the continents. That is absolutely ridiculous, that is stupid. Wagner was made fun of. Wagner was ridiculed. He was banned from various scientific communities. They, in fact, even convinced F.B. Taylor to issue a public statement at that point of time that, look, I've got nothing to do with the continental drift theory. I only said that the continents could move, but Alfred Wagner is saying something which is very stupid. Alfred Wagner was ridiculed, ostracized. The continental drift theory was rejected. But it was only decades later, in the late 60s and 70s, when more scientific data became available, when Alfred Wagner was vindicated. Obviously, he was long dead by that point of time. It was during one of his sojourn trips towards Greenland. That is when he basically died. Again, he left all this theory and he started continuing his study of climate change. That was his specialty. He started continuing that. And Alfred Wagner basically died as a person who was defamed at that point of time, who was ostracized at that point of time. It was only many, many decades later when Alfred Wagner was proved correct that yes, the continents indeed are moving. But then, here, we are going to study about the evidences which convinced Wagner that you had that Pangea and it moved. All those evidences are correct. But then we will also take a look at the reasons that Wagner provided, on the basis of which his theory was ultimately rejected. Now that we are wise enough, now that we know more about it, we can say that continental drift theory laid the groundwork in terms of the imagination that yes, the continents could move. It laid the groundwork, it helped people understand that yes, indeed, the continents could move. So the first person who can imagine that, you have to give credit to that person. For example, in the present day, when you think about it, the airplanes can fly. All of us, we know that. So let's suppose tomorrow you devise a new kind of an airplane, fair enough. You are a good intellectual, but always credit is given to the Wright brothers. Why? Because they were the first ones who thought about the airplane. They invented the airplane. So similarly, in the geographical community, while the entire world was talking about the fact that the planet is shrinking, here was a man who said that no, planet is not shrinking. You have the world which is actually drifting away from each other. So Alfred Wagner presently is given a lot of credit in terms of our understanding of the entire world. So here, when we talk about it, we will study the various different evidences. What are the evidences? What are the reasons why this theory was eventually rejected? Okay. Placer deposit is also an evidence. Good. See, some people are so very smart. Placer deposit and all, you know. Very nice. Okay. Let us assume we don't know everything, right? And let us start with our understanding. First of all, his basic idea which struck was that all the continents, they have a kind of a jigsaw fit, right? They appear to fit in a kind of a jigsaw puzzle. So here, all the various different continents, they appear to have, Vaibhav, don't worry, I'll tell it in detail, don't worry. So here, all the various different continents, they appear to make a perfect fit. That cannot be a coincidence. It can be a coincidence in some region, but it cannot be a coincidence in all the other areas. So this tells you that at one point of time, this would have been together. This would have been a unified landmass. Then furthermore, he looked at other evidences of geological rock formations. When a rock gets created, igneous rock formations happen by the method of radiocarbon dating, etc. You will be able to calculate the age of the rocks also, right? So he found out that the rocks in the region of the Appalachian Mountains here and the rocks in the Scottish Highlands, they have the same origin. They have the same geological patterns. They have the same mineralogy and the same time period. It cannot be a coincidence. It cannot simply be a coincidence that everything is same tens of thousands of kilometers. Similarly, he observed that the rocks here in the Brazilian highlands and in the region of Africa, they have a similarity. So basically, again, that cannot be a coincidence. So Wagner basically concluded that, look, at one point of time in history, North America was joined with Europe, South America was joined with Africa, and these continents have basically moved in the westward direction. Then, if we take a look at these geological evidences, similarity of geological structures across continents, and presence of similar mountain ranges across North America and Europe, Appalachians of North America, they are similar to the Scottish Highlands, similarity of geological rock structure in Western Africa and South America. Okay, then he also looked at placer deposits. What are placer deposits? Placer deposits, what are they? So basically, in an area, let's suppose here, you have a river which is moving. Okay. A river which is moving. Now let's suppose here you have a kind of a mineral which is not soluble in water, which remains insoluble in water. Let's suppose here you have a kind of a mineral. Okay. Now in this mineral, let's suppose we take the case of gold. Gold is not soluble, right? It is insoluble in water. Now, this water will carry these gold particles along with it. Slowly and steadily, it will erode those gold particles. It will carry it along with it. And it will deposit these particles somewhere here. Now, these deposits have been brought away from a far away place. And it appears as if they have been placed in this region. Okay. So these are what you know as the placer deposits. And this is what is known as the source rock. Because these deposits have taken place, these deposits have happened because of the erosion of the source rock. Okay. Now, in the western part of Africa, you find these gold deposits here. You find the gold deposits. But the source rock for these gold deposits were not to be found in the region of Africa at all. These were simply deposits. So the geologists always wondered where these gold deposits have come from. What is the origin of these gold deposits? Upon further investigation, it was found out that the source rock lies in the Brazilian highlands here, in this area. Now, how can it be possible that tens of thousands of kilometers away, You have the deposits which have been created. You have the deposits which have been created at such a far away place. How can it be possible? So that is where, again, he concluded that these would have been at one point of time unified, and they have now drifted away because he was convinced that South America has moved westward from the region of Africa. So placer deposits also hold an indication, right? So when we say placer deposits here, so minerals insoluble in water can be carried away by the rivers and streams and can be deposited at far away places, and that is, these deposits are placer deposits. Evidence supporting drift basically, you can have gold deposits of West Africa has got source rocks in South America. Okay, gold deposits of West Africa have got the source rocks which were situated in South America in the region of Brazilian highlands. So this was again one evidence. Another evidence was the glacial evidence. So wherever a glacier moves, wherever you have or you experience the movement of glaciers, in those areas, you will end up finding in the region of the glacial movement. Glaciers, by the way, they are massive, massive blocks of ice which are moving. So the force exerted by glaciers are oftentimes unparalleled. So wherever a glacier has been in motion, it will leave behind evidences. Those evidences cannot be left behind by river movement, by wind movement. They will not create such kind of impact or such kind of evidences. So such glacial evidences were to be found in the region of India, significant portions of India, southern part of India. They basically have the ancient evidences which indicate that glaciers would have been in motion there. Southern part of Africa, South America, Australia. All of these basically had evidences that you had glaciers in existence in these areas. Now, obviously, this in the present day scenario, it is hard to imagine that in southern part of the country you can ever have the movement or the existence of glaciers. It is very difficult to imagine that Africa could have the movement and existence of glaciers. Very difficult to imagine that South America could have existence of glaciers. So basically, upon taking a look at the geological structures, he found striations. Striations are the linear markings of sorts. They are the linear markings of sorts. So such glacial striations or such kind of linear markings on the ground surface that can be created only if that region has experienced a glacial movement. Observe this. It can be created only in an area which has experienced significant glacial movement. Only in those areas you will experience this striation. These striations were observed in the areas of southern India, in the areas of, for example, Africa, etc. For example, I'll give you an example. I hope that doesn't confuse you. We have coal, significant amount of coal in the river valleys of Godavari, Mahanadi, Damodar, Krishna. We have significant amount of coal. Now, beneath that coal, the rocks which are in existence, those rocks have a glacial evidence or a glacial structure formed. So that means before that deposit would have happened, which had led to the formation of coal, before that, the regions around the present day area of Chota Nagpur Plateau, around the region of Godavari, Krishna, etc., they would have experienced glacial movement. And also, wherever a glacier moves, it erodes the rocks, it scratches the surface. Very tiny particles are eroded and moved from the rocks. And these tiny particles eventually will get deposited somewhere else. So those tiny particle deposits that you associate, that is what is known as glacial till or tillite. Tiny particles which are deposited by glaciers. So, glacial striations and till or tillite deposits were found in peninsular part of India, Africa, South America. Striation, the meaning is straight sinuous lines. So the striations, these are your striations which get created. And Australia. Now here also an explanation could exist that what if in the previous ice ages these regions would have been frozen and now these regions have basically melted down, so ice has melted down, so you don't have ice anymore, right? That can be a kind of an explanation for that. But even during the ice ages, India never, in the present location of India, freezing did not happen in the tropics. Freezing basically happened in the temperate areas. The tropics considerably remained ice free. So that basically meant that the climate of the planet has not changed so drastically for a very, very long period of time. Right? So he looked at these evidences of the regions which experienced glaciers. It did not make sense to him. But then, if you put them all together, that is when it makes sense. If you put them all together, that makes sense. So he said that, look, at one point of time, all these were present in the region of South Pole and they have drifted apart. So this helped him to formulate a kind of a movement again. That is, movement of the continents away from the poles. Movement of continents away from poles towards equator. But as I told you, Wagner carried out a very detailed study. He did not limit his study only to a certain particular criteria, only to a certain particular set of characteristics. Wagner carried out a detailed study even of the fossil records and the remains of the fossils. He found out certain types of fossils which basically are to be found in areas spread across the world. For example, Mesosaurus. Mesosaurus is a freshwater reptile, right? A reptilian species. It would be of the length of around 8 to 10 feet, and it would exist only in fresh water. The fossils of Mesosaurus were to be found in South America also, in Africa also. How is it possible that the regions which are separated so significantly by thousands of kilometers of sea, how is it that a freshwater reptile can move into the region of Africa? Impossible. Lystrosaurus. Lystrosaurus was one of those species which survived many mass extinctions. Lystrosaurus was very unique, in the era where the reptilian large reptiles would dominate millions of years ago, when you had very large animals, very large anthropods. For example, present day, when you take a look at worms, for example, the worms, the millipedes, the centipedes, they appear to be very small. You can hold it up in your fingers, wrap it around, throw it like a ball also. That is how innocuous they appear. Imagine an era where these insects, millipedes, etc., they were of the size of 2 to 3 meters. So, in that era where the you had very very large reptiles, dinosaurs had still not come into existence. Now, due to various events of volcanic eruption, etc., you had almost all the species which went extinct. Lystrosaurus remained because Lystrosaurus would dig burrows into the ground and it could remain. But the fossil remains of Lystrosaurus can be found in Africa also, India also, Antarctica also. How is it possible that in these faraway places you can have simultaneous existence of this Lystrosaurus? How is it possible? Cynognathus, again, a land reptile. You find it in various areas. Glossopteris, ferns and plants, you find it in large areas. So that is where it was very baffling. Now, it goes against the entire theory of evolution. Theory of evolution tells us what? Theory of evolution you would have studied. Charles Darwin provided that theory of evolution, that species, they come into existence, they basically evolve, adapt, and then they spread out. You cannot have simultaneous growth of species in, or simultaneous evolution of species in different areas. The same species will spread out. The same species will move to different places. Right? So, these fossil evidences, what is referred to as the paleontological evidence, this is what is paleontological evidence. This also pointed out to the fact that everything would have been unified, it simply moved away. Cynognathus was 3 kilometers long inside. 3 kilometers long? It is 3 meters, my dear friend. Can a species be 3 kilometers long in size? Again, the innocence. Okay. So, slow claps for you that for a brief moment you imagined a species which could be 3 kilometers long. So, from my side, I can simply appreciate the level of immersion that you have put into the subject. Very good. So, basically, these were the evidences which all tell us, which all told Wagner that everything was together and it simply moved away. Now, till now, it makes sense. It would make sense to you also that, okay, that this is what would have happened. Now, when you provide a theory, you need to provide the reasons. Why do you believe that this is happening? This is where things started to go wrong. So, what was the theory exactly? The theory was that you had this large Pangea which was surrounded by Panthalassa. It drifted away, it moved away, and you have the westward drift of the continents, two kinds of motions. Or all their species of dinosaurs? No, Dhruv. Many of these species that you see, they have been in existence much before dinosaurs as well. Dinosaurs basically, they started dominating the land around 250 million years ago. You have in environment, if we get an opportunity, we'll talk about the various phases of extinction where dinosaurs, they basically started dominating the land at a point of time when all the other giants at that point of time were already extinct, and dinosaurs took to the land. They started dominating the land, and it was during the time of the dinosaurs when things started moving away. It is said, we do know by evidences now, that it was during the time of dinosaurs, and dinosaurs had come into existence, and there was some such amount of variation that dinosaurs, they were the only species who had the variations which could take up to the skies as well, who could be herbivores, carnivores as well. So when the land basically got divided, dinosaurs were left in each of these lands, and then they dominated. And did they dominate the land? They dominated the world around us for close to around 200 million years. Again, as I told you in the first class itself, had there not been an asteroid impact 65 million years ago, you and I would not have been in existence. Dinosaurs would be roaming this planet even today. And they were one of the most evolved hunters that the world had seen. But nonetheless, here, this westward drift, as per Wagner, westward drift of continents and then you basically had movement away from the poles. Away from poles. In German, he talked about the movement away from the poles. He referred to this as Polflucht, which basically, if you take an exact literal translation of it, it comes out to be flight away from the poles. Okay. Do we still find the remains of them? Yes. That is how we have the evidence. What could be the reason for such large body size? The sudden dominance and increase in oxygen in the atmosphere that allowed the metabolism rate to increase exponentially, where they could support the large body structure and large body size, and also the kind of temperature which was prevalent. It was very hot at that point of time. So it was basically the temperature in different areas supported the growth of larger species. But then he said about the drift, about the westward drift of the continents and the movement away from the poles. Now, in order to support or cite the reasons, he made certain assumptions. So, assumptions, what were the assumptions made by Wagner? Ankush, for your question that why is it that the continents appear to be like inverted triangle, it is how the land broke away. And when you study about how the land actually breaks away with the help of plate tectonics, you will get an answer about that. Assumptions made by Wagner. So Wagner he was not an expert about the interior of the planet. So he basically made an assumption. He said continents, which he referred to as Sial. Sial basically means silica and aluminium, right? That is what he referred to as the continents. Float and move freely over oceans. And he referred to the oceans and the ocean bottom as Sima, silica and magnesium. He further went on to say, just like a boat floats on water. So, just like a boat floats on water. So, how does and why does a boat tend to float on water? Basically, you would have read about Archimedes in your class 6th or 7th standard. Archimedes principle, which basically means that whenever there is a kind of a flotation, right, anything which floats, there is a force of buoyancy. There is a force of buoyancy which keeps it floating. So, if let's suppose you are unable to imagine that force of buoyancy, think about it, a piece of thermocol, and thermocol floats on water, it doesn't sink in water. If ever you try to push that thermocol to the bottom of the bucket, you leave your hand, again that thermocol comes up and starts floating back up again, right? So that is what? That is the force of buoyancy, which makes it move upwards. And also, heat, and as per this assumption, it means that the continents are moving freely. So as per this, you had two implications. Implications were, first of all, continents could move freely without any resistance. And secondly, continents experienced a force of buoyancy. Now, with these assumptions, he basically used these assumptions to solve the problem about these two movements. So now let us take a look at what are the reasons that he cited. So the first reason that he cited to support the westward drift explanation that he provided, it is not my explanation, it is Wagner's explanation, which was eventually rejected. Explanation for westward drift, because he was convinced that look, North America was joined with Europe, South America was joined with Africa, Pacific Ocean, Atlantic Ocean has come into existence very recently. Explanation of the westward drift. So, he said gravitational pull of sun and moon. So how was that responsible? How is it that the gravitational pull could basically lead to the westward drift? Listen to this carefully, try to understand it. This is planet Earth, and this was again Wagner's explanation. Okay, and on one side you have Sun. Now, he said that look, the continents were joined together and the continents would be rotating, or the planet would be rotating in a continuous west to east direction. Continuous west to east motion would be observed in the planet. But the gravitational pull from the moon and the sun would be so strong. While that gravitational pull would not be enough to move the earth in itself, to hold the earth in its place itself, but definitely that gravitational pull would be enough to hold the continents in their place. So basically, what did that mean? That meant as the planet, let's suppose this represents a continent, so as the planet would be rotating, the continents would be left in its own place and the planet would rotate. So as the planet would rotate and the continents being left in its place means what? You are observing what? See, this is the west to east motion. West to east motion is happening and the continents are left in their own place. So what is the motion of the continents if you take a look from the ground surface? So as the continents are held in their own place and rest of the planet is rotating, so it would appear that the planets are drifting in the westward direction. Right? So he said that gravitational pull of the sun and the moon were so strong, it held the continents in their own place. As the planet would rotate. Because remember, he talked about the fact that the continents are freely floating, planet would rotate underneath them. Okay, so basically, the planet would end up rotating underneath them. That is where they would consistently be rotating, and the continents would be held in their place, and the planets would be rotating underneath them. Right? So, if let's suppose you are an individual standing here, and the continent, Patel, now take a look at it carefully. Okay, I think it's Twisha, right? So, basically, think about it that here you have the continent, you are standing here, and the continent is being held in its own place and the planet is rotating. So for you, what will be the direction of motion for the continents? For you who is standing on the planet, the continent would appear to be drifting westward, isn't it? So that is where he said that this is the reason why, because of that tidal force, he referred to this as a tidal force. Because of that tidal force, the continents would be held in their own place, and it would appear that they are drifting westward. But what is the reality? The reality is it is incorrect. Had the gravitational pull extended by the sun and the moon be so strong, had the sun and the moon and the lunar forces would be so very strong, the rotation of the planet would have stopped within 50,000 years. But that is not the case. The planet is still rotating. So obviously, that is not true. That is not correct. Okay. So that is basically what he postulated, what he said. Okay. So imagine here, everybody has understood this. Is there an issue in understanding this? Any issue? No? Understood? Okay. I'm going to repeat it once more. Think about it now. So he said that the continents are freely floating. Don't, again, I would say, don't judge it by today's principle that how can it happen? Obviously, this was incorrect. So basically, suppose this is the Laurasia, this is your region of Gondwana land. Now, the planet is consistently rotating, but the continents are being held. So, that is where the entirety of the continent cannot be held. Maybe it will break. As it breaks, the remaining portion will start drifting away. The remaining portion will start drifting away. But this portion would be held by the moon and the sun. So, if you are an individual standing here, for you, what will be the motion for this particular continent? Won't you see this continent to be moving in a westward direction on yourself? Is that understood? Is that imaginable now? Garima, then Sonu. Is that understood now? Okay. So basically, in reality, this is not correct because had the gravitational pull of the sun and the moon are not that strong. Had the gravitational pull been so very strong, the entire rotation of planet in itself would have stopped. But basically, the planet continues to rotate. So obviously, the gravitational pull of attraction is not that strong. So this is incorrect. Second reason that he cited was to explain the movement away from the poles. Explanation for movement away from poles. Away from poles. Okay, or what is referred to as a flight away from poles or pole fluct. So basically, he said that look, planet Earth is not a perfect sphere. Okay, it is not a perfect sphere, it is slightly bulged around the region of equator. Slightly bulged around the region of equator. Now, as the planet Earth rotates on its axis, there will be centrifugal force. I hope we are aware what is a centrifugal force. So what is a centrifugal force? When any object moves in a kind of a circular motion, it will experience a force away from center. That is a centrifugal force. For example, let's suppose you tie a ball to a string and you rotate that string with your hands. You will experience that force where the ball will try to move away from you as you try to rotate. So that is the centrifugal force. Now planet Earth is consistently rotating. Speed of rotation is highest where? Where is the speed of rotation is highest? Good. Equator, isn't it? The speed of rotation is always going to be highest at equator, right? So because the speed of rotation is going to be highest, there is going to be the centrifugal force which will act in outward direction here. Again, remember, he said that the continents are freely floating. So if they are freely floating, they will be impacted by that centrifugal force. So, as per him, continents experienced two forces simultaneously. As per Wagner, continents experienced two forces. What was that? One was the centrifugal force, or centrifugal force is the force acting away from center. Other was force of buoyancy. Okay, one was the centrifugal force, other was the force of buoyancy. Okay, now in this case, in this particular situation, think about it. Force of buoyancy pushing you upwards, centrifugal force attracting you towards equator because the centrifugal force is acting away from equator. So all the, let's suppose you have a continent here. Now that continent would basically be attracted towards this. This would be the force. If you have a continent here, that would be attracted like this. That is why the continents around the region of the poles, they started breaking up and they started moving towards equator. Okay, so because of a combination of these two forces, he said that the continents would basically break up and they would be concentrating around the region of equator. Now, was this correct? No, absolutely not. It is very, very incorrect. Why? Because first of all, the continents are not your freely floating boats on water. Continents are giant land masses who have a connectivity to the mantle as well. You cannot expect the continents to be floating like boats. So that is simply not possible. And secondly, even if the continents would be floating like this, still, all of them cannot simply accumulate at the region of equator. When we talk about the region such as India, it has moved from the region of southern hemisphere to north of equator. If that would have been the case, India would never have moved to the north of equator. If that would have been the case, Britain, Russia, they would have never moved to that area. For example, Britain, if I give you a kind of a detail of it, Britain is very rich in coal, very rich. And the coal deposits of Britain, if you analyze them, they give you an idea, they give you an implication that this coal would have been created as a result of deposition of trees, which would be present in the tropical and equatorial areas. Same is the case with the coal seams in Russia also. They also, the trees which would have formed that coal, the evidence indicates to us that they would have moved, or these were the trees which at one point of time would be present around the region of equator. So clearly, region of Britain, etc., they have moved northwards. If this would have been true, all the continents would have, all of them would have accumulated only around the region of equator. So because this was incorrect, along with the reasons and along with the assumption, that is where Wagner went incorrect. And due to this, the entire theory was junked. The entire theory was trashed. Nobody at that point of time gave any importance to the fact that what Wagner was actually saying with respect to the drift, that drift could indeed happen. Fair enough, the reason was not correct, but that drift could actually happen. Nobody thought about it in that direction. Everybody concentrated about ridiculing Wagner, ridiculing Germans, ridiculing German scientists, and so on. So in that ridicule, Wagner was ostracized, he was defamed, and he left all of this. He continued with his own solemn journey and his own study about the ice sheets of Greenland and studying about the climate change. It is during this when he died, a kind of an inglorious death. where Wagner basically died as an individual. At the time of his death, there was more fun made of Wagner than anybody who could recognize the good work that he had done. And the irony of the matter is that his theory was rejected based upon the incorrect reasons that he provided. 50 years later, 50 to 60 years later, when American scientists they presented the plate tectonic theory, the reasons were not very clear that why that plate tectonics is happening. But still that theory was accepted. It is a theory that we still accept even today. So that is why I told you, many of the times in the scientific community, you have to be aware of where that scientific theory is coming from. When the same kind of postulation is provided where the reason is not very well known, but I can see its impact, and I'll tell you that impact which is happening. For Wagner, it was not a correct standard, but for the Americans, it was the correct standard. They were celebrated. Princeton and the various different celebrated universities, they basically celebrated all of these scientists who provided the plate tectonic theory based upon the same ideals that Wagner worked upon. But now we can say that it was the theory of continental drift which paved the way for that understanding that the continents indeed could move, and they could move from one place to another. Okay, so that is about the theory of continental drift, the reasons, the evidences, and why that theory was eventually rejected. Okay, now, don't you think it might have happened with the principle of inertia? Yes, eventually, Prem, you have to understand that once that gravitational pull of attraction happens, and as per Wagner, if basically he tells you that if the continental landmass was held in its place, then inertia would take over. But we know that that is not the reason why the continents do move. There's a whole together different reason, and that is associated with what is present in the interior of the planet Earth. Centripetal force is not clear. We have not even talked about centripetal force. Why do you want to understand centripetal force? We have talked about centrifugal force. Centrifugal force is the force acting away from center. Listen to this carefully. If ever you have tried to ride a bicycle in consistent rounded circles, ever, you would feel basically, if you have tried to do that, rather than the common logic which will tell you that you will fall towards the center of the circle, if you have done that, you will, if you have ever fallen in that experiment, you would always fall outside. You would have experienced this. If not, try doing that. Obviously, save yourself. But if you try doing that, in moving in a consistent circle, you tend to fall outwards. If you take a string and attach a ball to the end of the string, you try to rotate that string with your arms. Basically, you will find that you will get a force where the ball will try to move away from you, where it will appear that the ball will simply fly away from you. Try doing that. That is the force acting away from center in a rotational motion. That is centrifugal force. Okay, right? In future, after millions of years, can there be a chance to grow new continents? Absolutely, yes. Why not? So other continents moved towards equator due to centrifugal force, but what prevented poles from moving towards equator? Wagner was very consistent in the fact that around the region of Antarctica, all the continents were surrounding Antarctica. All these continents separated from Antarctica because of these forces. Because Antarctica was at the region of the poles, so it could not be impacted by centrifugal force. Okay. Now, that is the case of the continental drift theory. Now, after this is the kind of a previous year question which was asked. So we will discuss this and then we will move on into the convection current theory. So here, basically, the question which was asked and which has been repeated by UPSC multiple times What do you understand by the theory of continental drift? Discuss the prominent evidences in its support. So, when we talk about so how do you answer this question? So, when you answer this question in the intro, always, when you have two sets of questions, always in the introduction, answer the main question. What do you understand by the theory of continental drift? So, in the introduction, you will write theory of continental drift postulated by Alfred Wagner talks about the existence of a supercontinent named Pangaea and then the movement of the other continents or the breakage of the supercontinent and then the movement with respect to each other leading to the present day shape of the continents and oceans. That's it. It has to be concluded. The introduction has to be encompassed within 30 to 35 words. That's it. Okay. So that is where you write the intro about continental drift. Then comes the body. How do you start the body? Body should always have a natural flow from the portion of the intro itself. It should be you should not have the evaluator scratching their head that okay what suddenly there is a break. No, it should be natural. So basically here the theory provided by Alfred Wagner was based upon set of varying evidences from paleontological to geological. Then the question is only asking you about the evidences. So some of the prominent evidences. In mains, the pattern of questions are repeated, Mehtab. Yes. So the evidences, you divide it into jigsaw, fit, geological evidence, right? Glacial evidence, and write a couple of sentences or 3 to 4 sentences about it. Draw as many drawings and diagrams as possible. For every answer of geography, you have to draw a diagram. Don't think about it that this is a simple diagram. What will I draw? The evaluator would know it naturally. Fair enough. Let the evaluator know. But the purpose of drawing is if you draw something, even if it is not a good depiction, it provides that variation from the written text. And even if your written portion is, let's suppose, grammatically incorrect, or maybe you are not able to factually represent that, your drawing will do the talking. So that is where that drawing is essential. Be it a very representative and a kind of a customary drawing, it has to be drawn. For example, in the jigsaw fit, simply draw a rough map of, let's suppose, South America and the region of western portion of Africa. Just draw that. It need not be accurate, but it will do the job. That's it. Even if you do this much, it takes you 5 to 6 seconds. More than enough. Okay? Then eventually, it is a 10-marker question, so you don't have to talk about the reasons here. Conclusion, you can simply talk about the theory of continental drift was rejected because of the incorrect reasons cited by Alfred Wagner. But then, this theory paved the way for our better understanding of the surface and the earth and paved the way for the postulation of theories in the future such as the plate tectonics, which ably are able to explain the present movement of the continents and oceans. That's it. So in this way, you are showing continental drift theory in a positive light, at the same time highlighting that it was rejected. Okay, so it was rejected because you had the concept of you had the incorrect reasons that he cited, but at the same time he did some good work. Okay, right? No, glacial evidence not needed to be drawn in that case, but I am saying that for every answer, at least one or two diagrams need to be drawn for every answer. You should have the ability to draw. In fact, I will always move ahead to also tell you that your answer writing in geography, those of the candidates who are able to write good answers in geography, I have never come across any candidate who has written good answer in geography getting less marks in the entirety of the mains, because geography answer writing teaches you how to be descriptive and ensure good presentation with the images. So that will allow you to form flow charts, block diagrams, etc. Even in the case of polity, governance, sometimes even in art and culture, economics, more importantly, ethics, essay writing also sometimes. So not so much in essay writing, but in the GS4 and 1 to 4 GS subjects. So I have always seen in my past experience, I can vouch this with a kind of a certainty, that always it is the case that if you are writing good answers in geography, you will, I can give you a guarantee, you will score good in all the various answers, because then you would basically know how to explore that answer writing. You will be exploring and pushing the limits. Okay, right? So keep that in mind. Now,